Now that we have all the data in place for our app, we could look at the design for our first screen. This would be a grid of all the missions next to their mission badges. Now, the assets we added earlier over here contain all the mission badges like this, Apollo 1, 7, 8, 9, 10, and so forth. All the way. You can see the name is just Apollo 16, lowercase, one word. Now, over in our missions JSON here, we have these ID numbers that match the same thing. ID 1, ID 7, ID 8, and so forth. So we could use string interpolation, just Apollo mission.id, for example, to get our image name, and then Apollo space mission ID to get the right display name for the mission. Here, though, we'll take a slightly different approach. We're going to add some computed properties to our mission struct over here, send the same data back. This will be the same thing. Apollo 1, Apollo space 1, nicely written and so forth. But now that code's in one place in this mission struct, which means any other views can use that same data without having to repeat the same string interpolation code again, which in turn means if we change the way they look in the future, if we change the image names over here, for example, maybe we decide actually we want Apollo-1 or something, for example, in the future, it'll work everywhere in one place. Just change it in one file, everywhere updates automatically, which is much nicer. And so now in our mission struct, we'll add those two properties. We'll say the display name is a string, and that'll be the string Apollo with a capital A this time, and then string interpolation ID. And for the image, that'll be a string with just Apollo and then ID, now all lowercase with no space in there. With these two new properties in place, we can take a first pass at filling in our content view. You'll have a navigation stack with a title, then a lazy V-grid inside a nice scroll view so it works vertically. I will then use our missions array we loaded earlier, this thing here, as the input for that grid there. And each row will be a navigation link showing the mission's name and the image and the launch date of that mission, if there is one. The only small complexity, of course, is the if there is one part, because the launch date is an optional string. So we've got to use nil coalescing to provide a default value for the text view to display if there isn't a real date in there. So first things first, in here, we're going to make a property to make an adaptive column layout. So we can have the right number of rows and columns in our view, depending on our screen size. So I'll say we have an array called columns, and this thing contains one grid item with adaptive. I'll use minimum of 150 and no maximum. So it can grow to bigger if it needs to be. Anyway, inside our body property down here, we're going to say we have a nav stack with a scroll view, then a lazy V-grid, the columns of that columns property, and then for the content of the lazy V-grid, that we loop over our missions array with a for each of missions here. One mission comes in, then our navigation link to show more information. I'll say it's navigation link here, with a text of just detailed view for now. We'll fill it in later on. And the label for this, what to show on the screen, will be a VStack containing the image of the mission image, which is resizable and scale to fit with a frame width of 100 and height of 100. Let's go to interactive mode like this rather than selectable mode. There we go. Then below that outer VStack will be a second VStack here. This will have the text of the mission's display name in a font of headline, like that. Boom. Then we'll do a text of, scroll down, mission launch date. Again, it's optional. So I'll use nil coalescing NA, did not launch, in a font of caption. And this one will have a frame max width of dot infinity, like that. Then for the main scroll view, so the one inside navigation stack, that's this one here. I'll give this thing a navigation title of Moonshot, like so. Okay, I know, it looks pretty ugly right now. We're going to fix it up in just a moment. First things first, let's focus on what we have so far. We have a scrolling vertical grid where we have resizable images inside there that are scaled to fit with an exact frame here. So we keep the correct aspect ratio of the badges, no matter what size they are. Then, if I press Command R, run it back, we should see it's kind of okay. I mean, it's a starting point, right? The main problem you'll see is our dates are pretty wonky. 1968-10-11 and so forth. It's not the way people read dates, right? We can look at this one and say, okay, that is going to be July the 16th, 69. Just read it kind of second, third, first, for example. But it's an unnatural date for most people. I think Japan uses that date format, but most of the world does not. We can do better than this because Swift's JSON decoder type has a property called a date decoding strategy, which determines how to decode dates from here. We can provide this with a date formatter that describes how our dates are formatted. In this case, it's year, month, day. 69, 7, 16, right? And so in date format land, that is YMMDD. A year, then a dash, month, and a dash and a date, right? And we'll use that format here to load it out. Now you've got to be really careful here because date formats are extremely precise. You can see here it's 03 and 03 here and 05 and 07. That's what we call zero leading numbers, meaning that July isn't just 7, it's 07. We've got to do double M, meaning zero leading here. The same for days as well. 03, we've got to do DD for zero leading days. In particular, just to really screw with your head, you've got to use capital M for months and lowercase d for days. This is because you also have hours and minutes and months and minutes, and M is confusing, so the case sensitive matters. One means hours and minutes, one means days and months, right? Anyway, we'll get it in code now. In our bundle decodable file here, here's our decoder being made. We're going to modify this thing to be more complex. So we're going to say that we have a custom date formatter in place. So a new formatter here is a date formatter. And this formatter has the date format of Y-MM-DD. Exactly like that. The year in a natural format, 0 leading months, 0 leading days. Again, lowercase m means minutes. Do not do lowercase m. Do not do a single m. It's double M capitalized like that. And now we can use that for our decoder. We can say our decoder has a date decoding strategy. Be careful, that's not a date decoding strategy. You want date decoding strategy of formatted using our formatter like that. So telling our decoder to parse any dates it finds using this exact format we have specified here. Now, when working with dates like this, it's a really good idea to be specific about your time zone. Otherwise, your user's time zone will be used when parsing dates. In our case, we're displaying the dates in the user's time zone as well, so there's no problem here. But it can be important elsewhere. If you run the code now, you're going to find things look identical. Nothing's changed. We've still got year, month, day, right? That's okay. Swift doesn't actually realize that this date here is a date. That's because in our mission file, we said the launch date is an optional string, not a date at all. But now our decoder knows how to handle dates in that exact format we have. We can say this thing is actually an optional date instead. And now our code won't even compile because over here, we're saying show the launch date or NA. So we're trying to get an optional launch date, an actual date optional here, in a text view directly, or somehow replace it with a string if it's empty. This is another place where a computer property works better. We can ask the mission itself, give us a formatted launch date, please, for you, that converts the optional date into a neatly formatted string or sends back NA correctly for us. This uses the same formatted method we've used elsewhere, so it should be familiar to you now. Back in our mission struct here, we're going to say we have a formatted launch date property, returning a string. This will send back our launch date, formatted, with the date being .abbreviated and time being omitted. If that fails, send back NA as a string. And now in our content view, we can say send back the mission formatted launch date like so. And now all being well, our dates should appear in a much more natural format. Boom. Oct 11th, 68, March 3rd, 69, and so forth. It's much more sensible for the user. And we haven't said how to specify the date. So it'll still be translated correctly for French or other languages, for example, or it'll be rearranged if you're in a different locale where it's like day, month, year, for example. We'll just said format correctly with the abbreviated date. It'll take care of the rest for us. Now let's focus on the bigger problem. Our layout is pretty dull, right? To spruce up a little bit, I'm going to show you two useful features here. Firstly, how to share custom app colors easily, and secondly, how to force dark mode, a dark theme, for our app. First, colors. There are two ways to do this, and both are useful. One, you can actually add colors to your asset catalog directly. Add colors right here. You just say a color set and do them right here. And that's great. Or you can do it as pure Swift code. It's down to you. Both have their advantages. You know, if you do it in the asset catalog, get a nice visual color picker with sliders and stuff to choose from. But I find using code makes it easier to track when you have teams of people using GitHub, for example, because you can see the code right there in your source code, Nextcode, or on GitHub to monitor changes very, very easily. Although I prefer the code approach, basically, because it's just easier to work with on Git. Anyway, we're going to place new colors as names as extensions in Swift. Now, we could do these as extensions on the color type. There's a new color here right now. And if we do that, we can use it in a handful of places in SwiftUI, which is nice. But SwiftUI has a better solution because color conforms to a bigger protocol called shapestyle. And that's what lets us use colors and gradients and materials and as if they were the same thing. We just say background, ultra thin material, for example, or linear gradient, and they all work. This shapestyle protocol is what background uses. And so, if we want to do this really well, we should extend that rather than color. If we do that, then we'll access the same modifiers that shapestyle uses elsewhere. Let's use a really precise extension, which means we want to add functionality to shapestyle, but only for times when it's being used as a color. So let's do the code now. Press Command N, make a new Swift file. Call this thing color-theme.swift and give it this code. So you want to extend shapestyle, but only where it's being used as a color. And here we'll add two custom colors with exact red, green, and blue values. Let's add import SwiftUI. There we go. And I'm going to say static var dark background is a color. It'll send back a color with red 0.1, green 0.1, blue 0.2. And then static var light background. Another color. Send back color red 0.2, green 0.2, blue 0.3. So we have two new custom colors called dark background and light background, each of which has precise values for red, green, and blue, slightly more blue than red and green in both cases. So there's slight shades of blue in this case. But more importantly, we place these inside a shape style extension. And so we can use these colors everywhere SwiftUI expects a shape style to use. I put these two things into action immediately. First things first, in our content view here, we already have this VStack here, the inner one, containing the display name and the formatted launch date with this max width infinity thing here. We're going to add some extra code to here. I'm going to place before the frame a little bit of padding vertically, like that, and then apply a background of light background after the frame, like so. We get that effect. And now the outer VStack, this one here. This is the whole label for a navigation link. This thing here. What we want to do here is we want to draw a box around here. So there's a little box inside our grid. This means drawing a line around it, then clipping the shape just a little bit. And so we'll say this VStack here has a clip shape of .rect with corner radius of 10. And then we'll overlay this with a bit of spacing here nicely. There we go. With a rounded rectangle, corner radius of 10, stroked using light background, like so. So there's a nice little rounded rect shape here for each little card of our views here. Third, we want to add a little bit of padding here so these things get away from the edges just a little bit here. And so we have the images here, that's these things here. We're going to add a little bit of padding to that thing after the frame. So I'll say there is some padding here. Boom. Nice spacing around it to keep it nice and centered inside that box. We're also going to add some horizontal and vertical padding, bottom padding, to the grid. And so, look for your layout, find the grid. Do not choose the scroll view. We want the lazy V grid here, this one right here. Scroll to the end of that one. That's this one right here, and say you have padding both horizontally and at the bottom. Pushing in like that. If you add it to the scroll view, it'll look strange because you're also padding in its scroll bars, which will just look odd on the screen. As things stand, we're just making it inset around it, so the scroll bars go edge to edge still, but the contents are pushed in slightly like that. And now we can replace this background area here with the custom background color we made earlier, the dark background color. And that means adding a modifier here to the whole scroll view after the navigation title. We'll say there's a background here of dark background, like so. Okay. At this point, our custom layout is almost done. But to finish up, we're going to just look at the remaining colors a little bit. You can see the light blue color we have for our mission text, this color here, the button color, isn't great. And also, the Moonshot title up here is in black at the top because I'm in light mode right now, and so it's really hard to read against that dark blue background. We can fix both of these. We can fix the first one by assigning specific colors to each of our text areas. So the display name, and similar, I can say you have font headline and then foreground style of white. There we go. And for the launch date, I'm going to say you've got a foreground style of secondary, like that. Or it's okay. Maybe even go for white on that one too. Or grey. Grey maybe. Not quite light enough. Yeah, grey's better, I think. Grey's better. And then, if you want to, you could actually add a little bit of maybe, yeah, grey's fine. The other option is you could say white with like a opacity of something. So like a opacity of 0.5 or something. It's down to you. Have a go. I think secondary looks a bit too blue. So either go for white or go for a slightly translucent grey. It's down to you. Anyway, have a noodle around. It's your app. You can try it out. As for the Moonshot title, this text here, that belongs to the navigation stack, right? And that will either appear black or white, depending on whether you're running in light mode or dark mode. Now, if you're running the simulator, you can actually press Shift-Command-A to go between light mode and dark mode. So you can see it's changed between light and dark text up here. I'm in light mode now, so I get black text at the top here. It looks great in dark mode. You get white text, but it looks bad in light mode. We have black text here. To fix this, we can tell SwiftUI our view prefers to be in dark mode always. It'll cause a title to be white no matter what, and it'll also darken other colors. Navigation bar background, for example, will also change a little bit. And so we're going to find our main scroll view here. So scroll view right here. This thing, and say you prefer a dark color scheme. I'm going to say you have a preferred color scheme of .dark, like so. Resume our preview, and boom, get a nice bright white title at the top. So let's run the app now. So we think, there we go. There's our little grid. I can scroll around like that. Nice bright white scroll bar now because we're in light mode across the board. We get a nice dark navigation bar at the top because again, we're in dark mode now. And if you tap one of these things, it scrolls across to detail view. That's obviously temporary, but it's a great start.